Hello, everybody. Thanks for attending today's webinar. I'm Dan. I work as the Director of Wastewater Education at Aquafix, and I'll kind of be representing the lab today, handling the more technical questions you've got. And unfortunately, we don't have Natalie from the lab here today, but she is with us in the chat. Today, we're going to be covering Nocardia and Microthrix.
I'm Chris. I'm a technical consultant. I work directly with the lab, and a few of you I see on the chat I've had the experience of meeting with on site, and also just getting samples and working with information back and forth.
Generally, we collaborate quite a bit to be able to handle customer consultation and that sort of thing at Aquafix. But yeah, we're all kind of working together here. Why don't we start out with our first poll, just to get a sense for the audience here. How often does everyone here experience foaming? Well, as people continue to answer, it looks like we're getting a lot of people with on and off foaming throughout the year, which is interesting. Typically in the lab, we see a lot of samples during the window for Microthrix Parvicella foaming specifically. But yeah, if people are getting Nocardioforms or other types of foaming, that can certainly happen throughout the year. So we'll definitely make sure to address those things as well in today's presentation. All right, Aquafix Laboratories, we're a lab that deals with a lot of customer consultations and samples. We also run some treatability studies and that kind of thing. So definitely reach out to us at any point in time with questions. We'll have our contact information available at the end of the presentation. But yeah, we'll probably, if any of you send samples for identifying the cause of foaming or that kind of thing, we'll be looking at them. We are usually happy to do phone calls, that kind of things as well with our customer consultations. And aside from that, we spend a lot of time doing research and development of new products and things like that. All right, so when we talk about filamentous foaming, the two primary candidates for causing foaming would be Nocardia, or Nocardia-like organisms would be sort of a more technical way to refer to it, as there's a lot of different varieties of Nocardioforms, which can cause them to be more of a pain to treat because you're not just dealing with one filament. You might be dealing with 20 different types of filaments, and they all look very similar. So they might respond different to corrections in your plant and treatments. And the other filament is a little bit simpler to deal with, Microthrix Parvicella. That foaming filament is primarily associated with cold temperatures in fat soils and grease. So both of these filaments have some similarities about them, which is why they're both causing foam. Both of them have a fatty cell wall, and that means their cell structure is low density and it will float to the surface of the basin, which helps them contribute to foaming in wastewater systems. The other thing is because they have a fatty cell wall, they do a more efficient job uptaking grease than other organisms in the system. And because they can uptake grease more quickly, in cases where you have a lot of fats, oils, or greases entering your system, they tend to grow a lot more quickly than other organisms and can emerge in prevalence and start to take over the plant and cause some major foaming events and that kind of thing. Both of them can technically cause bulking and high TSS. I've seen that a little bit more with Microthrix, to be honest. Nocardia sometimes will contribute to floc disintegration if it's growing within the floc at really high levels. Basically, you get a bunch of filaments, they have a fairly low density, and they start to try to float to the surface, and they might take chunks of the floc with them on their way up. And Microthrix, I tend to see a little bit more tangles going into the bulk liquid, which can prevent a little bit of settling of sludge. I've seen some cases where people will lose nitrification and that kind of thing because Microthrix is doing some damage to their cell structure. But yeah, both of them are going to thrive because of fat. Microthrix Parvicella tends to like the cold a little bit more, and Nocardia tends to like high sludge ages a little bit more. But they both tend to be more common in the winter. Of course, other causes of foaming, you can have things like surfactants, but we're going to be focusing more on filamentous foaming today. So here's our Nocardia-like organisms. They tend to be fairly easy to identify under the microscope if you know what you're looking for. Nocardioforms are the only organism, aside from some fungi, that you'll see in wastewater that have true branching, which means they aren't just two filaments kind of stuck together. They're actually growing in multiple directions. You can see a couple pictures here. On the top, we have two gram stain photos. Gram staining is a good way to identify Nocardioforms. Basically, when you gram stain, gram-positive organisms become sort of a purple or blue color because they're holding onto the gram stain, and the rest of the organisms are going to look more red. Nocardioforms have a fairly strong gram-positive staining result, and they tend to look a little speckly under the Neisser stain, which you can see on the bottom right. That's a different type of stain, which isn't super necessary for identifying Nocardia, but it also has a distinctive speckling pattern. But one thing to watch out for, if you're looking at it under the microscope on your site, I have seen some cases where there have been smaller S. natans structures, which can look kind of similar to Nocardioforms if you're not staining and you're looking at them at lower magnification. S. natans usually doesn't cause foaming, but it can trip you up if you think you're dealing with Nocardioforms and you're dealing with S. natans because they have very different preferences for plant conditions. All right, so our next filament is Microthrix Parvicella, which has some similarities here as well to Nocardioforms. It has a very characteristic blotchy Neisser stain pattern, which is very distinctive. You can see that in the photo that's kind of in the middle of the slide. There's a couple filaments that look similar to Microthrix Parvicella under gram stain. The most distinctive one would be N. limicola or Nostocoida limicola 1, which stains gram-positive as well, but it tends to stain strongly Neisser-positive for the entire filament, whereas Microthrix just has Neisser-positive granules. They also look a little bit different in shape and that kind of thing if you're more experienced identifying filaments, that kind of thing. But yeah, this is the second one, and like I said before, it tends to prefer the winter. Another interesting note on Microthrix, we've noticed it in anaerobic digesters a number of times. Now, it can't grow in an anaerobic digester, but we found that Microthrix Parvicella, for some reason, can survive a very long time in an anaerobic environment. So we've seen some anaerobic foaming caused by Microthrix Parvicella associated with feeding of waste-activated sludge. And the Microthrix seems to survive in digesters for about a month. So if you have a lot of Microthrix growing in your activated sludge process, you're going to want to avoid feeding that into your anaerobic digester and trying to address the problem in the activated sludge process so you can prevent feeding of Microthrix Parvicella into your anaerobic digester because, you know, with the higher solids and volatile acids present, that'll be something you got to watch out for. All right, so why do these filaments prefer fats and thrive in high fats environments? The main thing, like I was saying before, they contain a lot of fat content in their cell structure. Now, this makes it more metabolically simple for foaming filaments to grab fat from the system than other organisms because most wastewater healthy bacteria have to go through a number of steps to effectively degrade fats, oils, and greases. But foaming filaments are able to grab relatively undegraded fats right away and store them within their structure. And because they're using them as a cell structure, it saves a lot of time and energy they would normally need to input and gives them a big advantage in environments with high levels of fats, oils, and greases. So why is this a problem? So a couple of things. In systems with high fats, oils, and greases, one thing you'll note is there's a lot of carbon loading, which a lot of heterotrophic, healthy, flock-forming organisms won't really love entering the system. If you have a lot of carbon, the unbalanced nutrients tend to sit around. So if you have excess carbon in the form of fats, your regular flock formers aren't going to really want to touch them unless they have adequate nitrogen and phosphorus. So higher fat loadings tend to leave the fat sitting around in the system for longer, which allows these foaming filaments to begin to grow more efficiently. The next thing I talked about was the degradation of fats by healthy wastewater organisms is a bit of a slow process. Now, first, when you have basically big blobs of grease entering your wastewater treatment system, you need to break it down into small structures through a process called disintegration. I have in some cases seen foaming filaments like Microthrix just attach to the side of large chunks of grease and begin to grow there, which gives them an advantage against other organisms in systems with high fats, oils, and grease as well. But once you've broken down these large chunks of grease, you need to do a process known as hydrolysis, which basically is breaking fats into long-chain fatty acids and glycerol. Glycerol tends to be pretty easy to degrade. It doesn't provide great energy yields to other bacteria, but it's not something that's really a problem in systems. But the fatty acids themselves, you need to go through a couple of steps to be metabolized as well. So the steps they need to go through to be metabolized are known as the beta oxidation process. So just kind of simplifying it here, they're going to be breaking down long chain fatty acids 2 carbons at a time. So in this example, we have lauric acid C12 breaking down into capric acid C10. Typically, you'll see C18 to C16 be the dominant fatty acid chains in a system if you're having a lot of fats enter the system. So you need to keep snipping off 2 carbons at a time to produce acetic acid, which is a good carbon substrate for heterotrophic organisms, but you're generating it very slowly. So you go through this entire process, whereas your foaming filaments are just going to be able to grab onto these fatty acid chains and synthesize them right away for fats in the structure, giving them a big advantage. All right, so now I'll pass this on to Chris here. So how do we decide, typically when you're working with customers, how do you handle treating these organisms in aerobic systems?
Usually we like to have them identified through some kind of microanalysis from you guys at the lab. From there, once you're able to identify what is prominent in your mixed liquor or in your plant, usually work backwards from there to understand what kind of environment, what kind of substrate that's coming in that's creating the abundance of a certain type of filament, such as Microthrix or Nocardia. In this case, we're focusing on Microthrix and Nocardia. Usually high amounts of fats, oils, and greases are coming in. Obviously, after we've confirmed that, we like to recommend our enzyme called QuickZyMel that showed your hydrolysis picture earlier. Helps with that process, in fact, speeds it up as a biocatalyst. Combine that with the foam buster, which is a biostimulant that then helps the metabolism of the bacteria in your wastewater to metabolize the extra carbon, etc., that's coming in from the broke down fats, oils, and greases that you're creating with the QuickZyme. From there, the combination of the two, along with a few sludge agents, you're able to basically outcompete the filaments themselves, which is the end goal.
Yeah, and just Chris did definitely talk about this already, but just when I was talking about the beta oxidation process, we're producing a lot of acetic acid. And acetic acid is a simple carbon substrate, which technically is easy to degrade, but if you release a lot of it at once, you tend to have excess acetic acid in the system and not enough easy-to-use nitrogen and phosphorus to uptake it all. And the idea of using Foam Buster is it helps provide supplemental nutrients so that bacteria are able to uptake these volatile fatty acids like acetic acid. Now, Chris, you mentioned that usually we like to do microscopy on foaming samples to make sure it's caused by filaments. That's something I like to caution people on. We have a lot of macroscopic or looking at foam on site just based on color and consistency, kind of guessing and speculating as to what type of foaming it is. And you can kind of do that. It's probably about 80% accurate. And 80% accurate, you know, if you have a chocolatey brown foam, that's kind of more of a scum, it's probably Microthrix Parvicella. If you have a thick bellowy foam, it's probably Nocardioforms. If it's something white and fluffy, it's probably a surfactant. But there's that other 20% of the time where you can get into trouble, identify the wrong issue, and be confused about why the foam isn't leaving your system, regardless of which treatment you decide to go with. So be a little careful with identifying the foam visually. It can be good most of the time, but if you notice you're trying to do a treatment and the foam is not going to go away, definitely consider that. All right, so now that we've covered all this presentation content, we'd like to open the door to questions. So this is full Q&A. Start off with things that are maybe more relevant to the topic at hand. But if you have any really questions about Aquafix as a company, questions about products we offer, feel free to ask pretty much whatever type of question you want. All right, so we have our first question here from a Jeremy. Does Foam Buster directly treat the foam? What do you think, Chris?
Well, not directly. As Dan stated earlier, the idea is to stimulate the bacteria to be able to metabolize what's coming in better. So over a certain time, in terms of mixed liquor, sludge ages, they will be able to outcompete and thus outpopulate what the filament is. Not necessarily directly treating what foam you'll be seeing on your basins.
All right, another question from Jeremy. What mechanically should I do to improve the removal of foaming filaments? You know, that's typically the best approaches to deal with foaming mechanically would be Removing the foam, I've seen some sites use like a vacuum truck to basically suck the foam out of the system. I've seen, some people have skimmed off the foam with things like making a ramp in their system. There's a couple of strategies, but it is nice to mechanically remove the foam because the filaments do like to concentrate there. So it's a good way to remove a lot of foaming filaments without taking out a lot of solids in your process. We also typically do recommend increasing wasting of sludge. Wasting generally will favor flat-forming organisms over filaments because flat formers tend to grow more quickly than filaments because they're growing in all dimensions rather than in a line, and their structures are a little bit simpler. So yeah, if you waste a little extra sludge, you're taking out filaments and you're also encouraging new bacterial growth, which is good at dealing with foaming. All right, we have a question from Tony.
Tony asked, do you need to use the quicksime and the foam buster together? I mean, it depends case by case. For your best opportunity to treat and outcompete, then yes, we would definitely recommend utilizing both. As all of us know here, wastewater streams and wastewater plants are so unique and so different. Most of the time, we would recommend both. But yes, it has been opportunities that we've done just either one or the other and had really good success. Really what we would have to do is analyze your particular situation, either microscopically or through other characteristics, to really understand if one or the other would work better or if both is the best option.
I see a question from Greg. Can you compare using hypochlorite on Nocardia and Microthrix? So the use of sodium hypochlorite for the treatment of filaments can be effective, but it tends to be a lot riskier with Nocardia than Microthrix. Typically, worst case scenario with Microthrix, if you do chlorination for filaments, as long as you don't go totally overboard, it's just not going to do very much. Best case scenario, you might damage the filaments. It tends to be an effective treatment on filaments because they have a lot of surface area in the bulk liquid because they're sticking out of flock more. But Nocardia does not respond well to chlorination most of the time. Usually when we see people use sodium hypochlorite to treat Nocardioforms, it fragments into a bunch of little shards and it doesn't die, so it kind of escapes. And once it escapes, all these little shards actually can grow more quickly than the older filaments which were present before. So you can end up with a major surge in Nocardioform population after chlorination. All right, I see a question from Deborah. What should I do to reduce filamentous foaming if I can't remove the foam or increase wasting in my site? So that can be a major challenge, and it's a little easier to deal with Microthrix than Nocardioforms. But typically, I'd be looking at the whole system and try and figure out ways where I can reduce grease entering the system. So there might be an upstream treatment with some products that we can cover a bit more if there's any questions on them, like Greasezilla and Bug on a Rope, which can degrade the grease from upstream. You might be able to make tweaks to your pre-treatment system on your site to do a better job of removal of grease if you're having some issues there to deal with it as well. In some cases, we've also recommended the addition of a food supplement to grow flock-forming organisms more quickly, because that will sort of, in effect, reduce the sludge age in these cases as well, which can discourage the growth of filament somewhat. So we have our Smart BOD product sometimes we'll recommend in these cases if you're incapable of wasting. It is a way you can do a temporary reduction in sludge age as well.
I see another question here. It says, how to use for treated ammonia issues. I'm not extremely clear on what is being asked here. Do you understand what they're asking?
Yeah, are you able to clarify? I've seen some cases, just to broadly talk about ammonia removal. But yeah, if you can clarify at this point a little bit more, that would be helpful to address your question specifically. I would say I see a number of cases where foaming filaments can start to mess with flock structure, and a lot of them are going to be growing in colder temperatures or in systems that are kind of adverse to flock and wastewater bacteria are already. So if you damage the flock structure, you're kind of breaking up the home for nitrifying bacteria and causing them to wash out of the system, which, will lead to poor ammonia removal in a lot of these cases. And in those cases, if the filaments are causing the flock to break apart, you need to treat the root cause, which is the floc disintegration, which will be caused by the filaments. So you'll look at the type of filaments that's present and address it. If it's Nocardia and Microthrix, probably it's a grease or sludge age issue.
Next question. Is it best to shock treat with these products, or is it step feeding via metering pumps, and better solution is their water temp when these products best perform? I think more of continuous treatment of incoming water is going to be the best via metering. Water temperatures obviously are going to have effect on the biological activity, but usually that can also be a solution. These products can, when the temp goes down and the metabolic activity goes down, it can help improve that. Dan, what are your thoughts?
Yeah, just to add a note there, as the temperature decreases, what you're doing is you're nudging the competitive environment in the system a little bit, and organisms that are more capable of dealing with the cold tend to have a slight advantage, and the organisms that are not capable of dealing with the cold have a slight disadvantage. So with these products, a shock treatment doesn't really make a lot of sense, because the goal is going to be to tweak the environment so that you're favoring healthy organisms. And while you're doing that, you need to give the organisms enough time to grow. So I would say a lower dose. As far as the water temperature, which the products perform best, they typically will work fine in colder temperatures, where we've seen effective treatments, in the 5 to 10 degrees Celsius range, certainly. And it's not like they'll get so cold they won't work. It's more just the colder it is, the more you tend to favor filaments, which have an easier time uptaking solid grease.
How do I know what is causing my foam? Microanalysis, as Dan explained earlier, is probably the best way to understand what filament you're dealing with. As he said, visually, you can almost make an assumption off of certain characteristics of the foam and different characteristics of, a lot of people generally know what they have coming in for the most part in terms of fats, oils, and greases, temperature changes, and experience with their plant, because they've been working with it for a while and just understand at certain points they have certain challenges. My perspective is, if you truly know what you're dealing with, you're going to be able to make a better recommendation and take the appropriate steps to treat, or like Dan said, create the environment to promote healthier wastewater microbes.
Yeah, and just to add an additional note there, it can be confusing to tell what's causing your foam. Sometimes you'll have a little bit of a foaming filament in it, but it won't be enough to be the actual cause of foam. Sometimes you'll have another type of filament that just happens to be mixing in with the sludge in a way which it's going to be pushed up by aeration and might cause foam as well, or you could have a combination of things going on causing the foam. It can be pretty confusing. The safest way is looking at the foam under the microscope. But anyway, the idea would be you can look and compare the levels of filaments in the mixed liquor to the levels of filaments in the foam, and see if filaments are actively concentrating in the foam or if they just happen to be there fairly easily. So that's typically how I would go about identifying it.
One more here. Why should I vacuum off any foam off the basin when treating? From what I understand, that can move freely between the floc and the foam. So you're only going to benefit yourself and actually reduce the population by removing the foam. Am I correct in that?
Yeah, I think so. So just wanted to ask a quick question, because I'm just curious. Do people typically look at the foam under the microscope in most of your sites? I know a lot of wastewater operators have microscopes on site, so they're just posting the second
check this
here.
poll out. I met a few of you and a few operators that have their own microscopes. And it kind of ranges from whether they're comfortable with sitting and trying to identify what they may feel are filaments, and then trying to address what the actual filament is. So this is a good poll. If you're able to, just jump on there and give us some perspective.
All right, seeing a lot of answers coming in. That's excellent. So while they continue to trickle in, right now I'm seeing about 25% of people in the audience, maybe, or 36% actually, of the people in the audience don't look at the microscope. That's understandable. There's just so many things going on as a wastewater operator. And then of the other 4, we're kind of split. But yeah, it can be pretty confusing using the microscope to identify the cause of foaming, depending on what the type of foaming is and how subtle the different indicators are. But it's nice to see that a good chunk of you are looking at it under the microscope. And, if you're not able to look at it under the microscope on your site because you don't have one, you don't have time, that type of thing, sending out the sample to a company like us, Aquafix, to do microscopy on the samples, we should be able to pretty definitively identify your cause of foaming.
Yeah, that being said, we work with you directly to also in terms of the collaboration, understanding how your process works, to understanding as much as we can what your wastewater coming in is, and then other environmental characteristics, so that Dan and his team can better make an understanding of what you may have in terms of foam causing filaments. Like he said, it could be many different types, could be many different situations going on, and they're able to determine that with proper communication and obviously getting the right samples, etc.
So, out of curiosity, Chris, since you work with a lot of our clients over at Aquafix, how many people do you think you've worked with that have definitively had foaming at any time of year from Microthrix and Nocardia versus just other random things going on around the process? Any idea?
Probably 90+%. I'd say the 10 other percent is not really clear. It probably is, like you said, a combination of factors that can lead to foaming, but I believe it's this combination that leads to a prominent amount of Nocardia or a prominent amount of Microthrix foaming. So we like to make determinations, and we like to look at pictures. His team's really good in terms of determining just by visuals and characteristics. But a lot of times determining what it is microscopically is the best route. But yeah, for the most part, when it gets cold, it's generally some kind of filamentous, and working with the foam and getting it analyzed can prove it.
Yeah, do you think you have a sense for, I'm assuming most of our questions about foaming are caused, or it's turned out to be Nocardia. That's probably the dominant cause of foaming, right? Or do you typically see more Microthrix?
I'd say it's more Nocardia.
Yeah.
You see obviously a fair amount. My experience to it seems Nocardia just seems to be better. I don't know, at outpopulating, out competing, and taking the FOGs and just really establishing itself. That being said, it's also really seems to be more challenging to get out. It takes a little bit more time to outcompete it. It's very stable and very stingy when you try to you do everything properly, breaking down the fats, oils, and greases. You've gone upstream to mitigate what you have coming in. You're wasting heavier, you're getting your mixed liquor ages down, and you're still challenged after a couple sludge ages with Microthrix. I've seen that before. It could just be a very challenging and then obviously frustrating for a wastewater operator to have to continuously deal with and fight that battle.
Yeah, I feel like really long-term issues with Microthrix where it's difficult to treat are mostly a basis of sort of lacking pre-treatment and having a lot of grease entering your system, which can be a real headache in the sites, but it isn't maybe as widespread as Nocardia. Now, Nocardia just makes me angry sometimes because, there's probably 20, 25 different types of Nocardioforms present in wastewater plants. Some of them cause a problem, some of them don't. And it's just frustrating. Like your Nocardia might be more driven by fats. It might be more driven by sludge age. For all you know, you have some obscure form which might be driven by some sort of nutrient deficiency. Fortunately, if it is a filament causing foaming, you do know it has a decent amount of fat content in its cell walls, which means treating the fats will almost always help.
This one's a good one. What types of treatment plants are most susceptible to FOG filaments? Well, generally where you have like a bioreactor that happens all in the same spot, like an SPR, just because everything can coagulate right there and doesn't let's say dilute out throughout the system. Those can be challenging. MBBRs, sometimes again, because they can tend to have everything happening in one spot. Beyond that, generally it's more dependent on sometimes the age of the plant and their ability to treat what is coming to them. Like I said, plants that are challenged with wasting, and different types of plants that are just more susceptible, like mechanically. How about yourself? I mean, you've done a lot of analysis. What's your experience?
SBRs are really the big one for if you're having problems with filamentous foaming. I really only see like a combination of Microthrix and Nocardia both growing in bulk in SBRs in the winter. And that has something to do with, just having you have all your feed substrate go in, and it's able to come in contact with all of the organisms present in the system. And then everything has lots of times to grow on the substrate. In a long rectangular basin, you have almost like a selector at the front end of the basin where the DO is a little bit lower. You're seeing more like anoxic uptake of carbon, which removes a lot of carbon substrate more efficiently. And then the rest of your basin isn't likely to be loaded with the fats, oils, and greases and much, which just gives you a little bit of an advantage.
Yeah, one key is coming back to mechanical. You guys all know that mechanically we need to have everything operating appropriately because that's how it's engineered to be able to treat the water you have coming in. If you're challenged in certain ways that way, some of the other challenges that biology presents can almost seem unsurmountable. Next one. Hey, Matt, are your filamentous remedies wet testing friendly? I know we have SDSs on all of them. I can definitely find that information for you. I don't want to put my foot in my mouth and say yes, but I know we have SDS and pretty complete feedback on that. But if you have a specific one you're wanting to know about, just let us know at the end. We can get that info to you.
Yeah, we haven't seen any issues with that. Certainly, I would say at the dose rates we're applying, it should be wet test friendly. But yeah, if you have a specific question about one part of the wet test, definitely let us know and we'll get you whatever information we can on it.
It's a quick question. Anytime we use a kind of product in an aeration basin or ahead of the plant, like we would with Quicksign and Foam Buster, generally we don't have any issues from operators saying it affects their effluent in any manner. Usually, why is that? Is that usually because it's all used up or it's inactive as it goes out of the plant, right?
Yeah, I mean, most of it will be used up. And, a lot of the time when you're adding a supplemental product like that, it might be something that bacteria, if given the optimal conditions, would normally produce in a system. For example, your bacteria in a system will begin to excrete exoenzymes for the degradation of fats, oils, and grease. But so you'll have a blend of different things they're already producing, and the idea of something like Quicksign L is the bacteria aren't able to produce their exoenzymes quickly enough in a lot of these cases, particularly in colder temperatures. So you give them a bunch of similar compounds and they're able to uptake everything more quickly. But yeah, there are things that are kind of already there naturally in the system for the most part. It's just we're supplementing them because the system is having problems producing them.
Let's do this one. Does the product reduce active foaming or reduce foam that is already built up as well? This is a great question. Foam that's already there is already established. It's already collected its solids, it's already above the mixed slicker, and it's already on the basin. So generally, unless you took some kind of defoamer, which when it's pretty stable, like Microthrix and Nocardia, most defoamers won't have much of an effect long term. They may be able to knock it back a little bit, but generally sucking it off would be your best way. But if you are in a tight spot, you may be able to use a defoamer like ours to be able to do that. But for the most part, right away, it won't reduce the foam that's already established. What it will do is help, again, go back to the environment to create good biology and reduce the filaments that are causing the foam. And over time, that foam that's already currently built up generally works its way out, dilutes out. I've also seen where it doesn't. So even though you're creating, better mixed liquor without the filaments, you could still have that established foam. So that's why we're saying to get on the jetter truck if you're able. I've seen guys take hoses and sprays to break it apart, because if you break it apart while you're treating, gradually you're going to again create an environment where you don't have the filaments and then the foaming from the filaments.
Yeah, and I can interject one point there as well. If you're spraying or trying to knock down the filaments, typically we will recommend that in cases where you're ending up with enough foam that it'll become a real mess in your system. If you just have a little bit of foam, it's actually better not to knock it down with something like a defoamer or a spray, because your filaments are actually going to be happier in the bulk liquid interacting with a diverse variety of substrates than they are going to be at the surface. At the surface, they're going to be starting to kind of die there as long as they sit there. It's just, if you have so much foam that it's going to overflow over the system, using a defoamer like our Defoam 3000 or something along those lines can help to collapse it so you can get through the upset without having a huge mess on your hands.
And those small amounts of foam, like Dan was saying, sometimes it can just be a visual thing for most operators, but at the end of the day, if it's not harming any mechanical or anything like that, generally, if you can get over the side of it, it's probably fine.
Yeah, it can feel a little scary because sometimes you'll have quite a bit of growth all at once. But yeah, as long as you're kind of keeping tabs on what's going on with your system otherwise, and you have a little bit of foam, there are a lot of cases where it doesn't turn into a big disaster, and it is more of an aesthetic thing. I have a question from Chad, which is there any way to get a volumetric measurement on Nocardia to know how much enzyme treatment is right, or should I feed the enzyme? How much treatment is right, or should the enzyme be a continuous feed? So Quixime L generally should be a continuous feed. There's not a specific dose rate relative to filaments because you're tweaking the system. You're not using it to attack the filaments like you would with something like a chlorination treatment. What I will say is, technically speaking, you could come up with an optimized amount of Quixime versus levels of fats going into your system, but it's generally not something we'd approach because you tend to hit a point of diminishing returns fairly quickly when you're adding a product like Quixime L, where you can add 10 times as much. It'll degrade more substrate, but it won't degrade 10 times more substrate because the enzyme-based products kind of float around in the system and begin bumping into fats, oils, and greases. And then they kind of keep working until they're washed out of the system most of the time. I mean, they do eventually distort in shape and dissociate. But, basically, if you have time, they're going to bump into things. Adding more makes it so they'll bump into things more quickly. But the more you add, kind of the less benefit you'll get per volume.
Let's see what I see one next. Do you see more foaming in plants with primary clarifiers more than plants without primary clarifiers? I would probably say someplace without primary clarifiers would see more foaming throughout their basins, as primary clarifiers, a lot of that can settle out. They would probably just be more susceptible to getting grease in the aeration bioreactor area.
Oh yeah, I think primary clarifiers, if everything's working well, do a really good job at reducing foaming relative to not having a primary clarifier. I would say probably 75% of our filamentous foaming samples are plants without primary clarifiers. You just get a lot more fats entering the system. Unless you have another way to remove the fat, which is potential, but they don't tend to be taken out well by bar screens and things like that. They tend to get into the system in a lot of these cases.
What is the best way to be proactive about FOG filaments? I like the approach of keeping out what you don't want in your plant is best by working as far upstream as you can. Collection systems, restaurants, certain areas, industries, you guys know, can just add it and send it down the line, and it gets to you in terms of, the fats, oils, and greases from their byproduct or whatever they produce or whatever they sell. Neighborhoods that just tend to cook that way is generally the biggest issue. But if we're able to break the grease down, start making a difference there, we all know down the line that's going to be less that's coming towards our plant that ends up in our plant. The lab's designed certain products like our Greasola, which is a blend of biostimulants and bacteria itself that start working on the grease in lift stations, in collection systems, not only to help you in terms of keeping the lift station clean, keeping it from setting off alarms from your pumps and getting all of your walls, but it actually will help the amount of loading of grease that actually ends up at your plant, which is the overall key, and kind of, through testing and working with Dan and the guys at the lab, that they're able to understand that. So if we're able to keep the grease overall from getting to you and bring it in more broken down, not only is that going to help you in your plant, it helps you in your collection system, your lift station, your manholes, your wet wells, all that stuff.
Yeah, and one of the keys to being proactive with any sort of treatment in your system, foaming filaments, is just making sure your system is healthy. If your system is kind of staggering by and everything is meeting limits, but the bacterial health is not good, You might be holding a lot of additional sludge that you don't need. You're making it a lot more likely in your system that you're going to have a problem. Now, I know a lot of that may be outside of people's control, but like optimizing the health of your wastewater bacteria will prevent the growth of filaments purely because it's harder to outcompete something that's doing great. If your healthy bacteria are doing great, they don't get outcompeted nearly as much as if they were not doing great.
So that being said, is what we do at Aquafix is what's called a proactive microanalysis.
Mm-hmm.
That's an opportunity for a wastewater operator or a system to, as this question states, just be very proactive about the filaments beyond going upstream and making sure mechanically your plants are operating, your grease pit or the grease is being broke down as it comes down the line. This truly gives you an opportunity to send in quarterly or at your pace, analysis so that you can get direct comparison to the health of your bacteria as the months go on. I feel like that's probably the best way, especially if you feel like you have everything under control upstream. Microscopically, that's your best way, I feel, is controlling your FOG type filaments.
So the next one is a question from an Andre, which is, can ferric chloride treatment exacerbate foaming problems? I haven't really seen evidence of that, but it's not impossible. I would say sometimes ferric chloride can actually stress out the organisms a little bit in your system and lead to increased sliming and that kind of thing. But yeah, usually I haven't seen evidence of ferric chloride leading to foaming being worse or causing it. Have you had that experience? I'd be interested to hear about it.
If you got some experience on that, and if you've noticed it, let us know. This question seems more like indirect, but yeah, if you guys have experience, we definitely would like to learn more about that.
I have a question from an LCID. Do you see more of this problem in continuous flow reactors more than in sequencing batch reactors?
Yeah, you touched on that a little earlier. I agree. SBRs tend to where things can happen all in the same spot. It just builds up more. I think you brought that up earlier too, right?
Yeah. Ooh, a good question from a Deborah. Can you add QuickSime before a DAF? Will this interfere with the polymer used in the DAF? That's something I've been kind of on the fence about because technically speaking, QuickSime will work better in an area with more concentrated fats, which means if you're adding it after the DAF, it won't have as much substrate to act on. But if it is converting fats into fatty acids, some of them might make it through the DAF. So if we're talking about like a pre-treatment system or something, I would probably rely on the DAF as much as possible and add the QuickSime after the DAF because you're going to be more concerned about reducing a little bit of residual COD there at the end. If your system is potentially, if it does a pretty good job skimming off fats with the DAF, but you might be a little bit carbon deficient in your system, then you can deal with adding it before the DAF and it might help with foaming filaments and also add a little bit of supplemental volatile acids to the system downstream. But yeah, I would say usually I'd let the DAF do its work first because that's what it's for. You don't want to be breaking down. You don't want to be fighting with the DAF and trying to have two things kind of serving the same purpose.
Yeah, maximize, the effectivity of the DAF. Just let it do its job.
Yeah, and as far as interfere with polymer used in the DAF, I haven't seen enough evidence one way or another to know what the impact on the polymer and DAF will be. But my assumption is
I don't think it interacts much.
It shouldn't interact with the polymer. Yeah. The only reason it would interfere is if it was kind of liquefying the fats. Yeah.
Can your products interfere with a BNF as we do not treat with any chemicals? Could it harm nitrifiers or phosphorus organisms, both NNP removal?
I would say I've never seen any evidence of our treatment harming nitrifiers specifically. In fact, it will usually help the nitrifiers because if the filaments are interfering with floc, they are going to interfere with nitrifiers. It'll also help the uptake of BOD, and having high levels of soluble BOD in a system will mess with nitrifier function as well. Yeah, I don't think they'd be interfering with the BNF in any way. It's just if you've got filamentous foaming, they should be pretty safe to add.
This one's pretty straightforward. Will high sludge age help prevent outbreaks? Matter of fact, high sludge age actually can cause outbreaks. Usually when you have older bacteria, it's easier for filaments to outcompete them. That's why usually we recommend any kind of filamentous treatment comes along with increasing wasting and getting the slicker down. But that can be challenging sometimes depending on individual situations.
Yeah, and we've actually at Aquafix we've been working on a couple different projects to be able to verify, because there's always this question about, is sludge holding going to help me going into the winter? If I hold more sludge, aren't I going to maintain nitrifiers better? That kind of thing. And there's a trade-off you have to watch out for, where the higher your sludge age is, the more dead cells are going to be making up that population. And there's a point where you're not actually increasing your active bacterial population at all. You're just kind of stagnating it. And you're going to be discouraging bacterial growth, which makes the filaments have more of a competitive edge. Next question is an interesting one from Chris. Do marijuana oils from a processing facility cause major problems for FOG? My guess is they do cause problems with FOG. We haven't tested our products specifically on like CBD oil, that kind of thing. We have tested them on a pretty wide variety of fats, and I don't see any reason why it wouldn't work. Yeah. If a lot of people are concerned about CBD oil or things of that nature specifically, it's something we could potentially take up and do more studies on. But yeah, I don't see why it would be different than other fats, oils, and greases. I'm sure they can cause foaming, and I'm sure that our product should be at least somewhat effective on it.
Yeah, if you have more questions, I know I've talked to a few processing facilities. Just email us and we can get more in depth on it. It's kind of interesting. Seems like that's about it for the questions. We're going to put up another poll here. How do you typically handle your foaming? Now, this one's going to be good for us just to kind of learn a little bit about not only the audience that we were able to present to today, but also how people, that are coming to see what we're having to talk about, how they would handle it on site.
I'm so happy to see a lot of people are increasing wasting.
Yep.
One of the biggest problems we have in dealing with any treatments is places that are unable to waste. I think a few years back there was a lot of flooding a few years back across the Midwest, and we had so many places that were unable to land apply sludge, and all of their sludge storage tanks were filling up, and they were all freaking out whenever they got filaments, because normally you'd like to increase wasting, but what do you do if you can't? It can be really tough. Chlorination. For people in chlorination, can you type in the chat, how does that typically work for you? How good are your results generally?
DO control. Okay. That's interesting. How would Matt, you give more information on how you do DO control for filamentous control? That's a good option. I mean, if people are able to do it.
Yeah, and DO control, just as a general rule, there's a lot of cases where it might work okay for filaments. We see a lot of sites that would work with something like an anoxic or an anaerobic selector to reduce the prevalence of filaments. But yeah, filaments like oxygen. Foaming filaments tend to like oxygen in particular, but the unfortunate thing is if they float to the surface, it doesn't necessarily matter what you're going to do. They're going to have some access to oxygen. That's one of the reasons they seem to like to float, is to get into that higher oxygen environment. The other thing is, how low is your DO going to go? There's a lot of filaments like H. hydrosis or S. natans, which are pretty tolerant of low DO, and sometimes I've seen them favored in cases where you might lower the DO to select away from filaments. Chad commenting here, chlorination is a short-term solution and non-selectively kills off good. Yeah, that's true. But sometimes, you can combine a short-term solution like chlorination with a longer-term solution like wasting and the addition of Quicks-IML and Foam Buster to kind of attack the filaments in multiple ways. They're not necessarily, contradictory things. It's just the danger is if you chlorinate, you have a high probability of messing up or killing good bacteria, or not killing the filaments well enough, and then they can actually end up being worse. Matthew here says, we found that keeping the DO between 2 and 4 helps to keep the filaments from growing as much. Yeah, that's definitely a good guideline for your aerobic systems. I definitely like to see above 2. Once it gets higher than 4, you're kind of wasting a bunch of energy. But once you get 2 to 4, you've got enough oxygen for your flock formers and nitrifiers to be happy. Question from Chad. Have we seen filamentous foaming in lagoon systems? We have. It's very infrequent. And the key I've found with lagoon systems is your lagoon might behave more like an aeration basin, or your lagoon might be more like an unaerated pond, and you might not have enough aerators to really have a mixed liquor the same way you would in a typical wastewater system. I would say if you have a relatively limited mixing lagoon environment, you're not likely to see much filamentous foaming. But if you have a really well-mixed agitated lagoon, it might behave similarly to an aeration basin. The other thing I have seen in lagoons is non-filamentous foaming from things like slime generation and surfactants, that kind of thing. That tends to be a little bit more common in lagoons. We have a question.
Does Foam Buster work to reduce all foaming filaments? It is designed specifically to work with the actual bacteria, the good bacteria in your system, with the end goal of outcompeting those filaments. So yes, it should help and reduce all the filaments.
Yeah, I would say there's 3 filaments that are dominantly considered foaming filaments. The main 2 are Nocardioforms and Microthrix. So the third one would be type 1863, but all 3 of these filaments tend to thrive because of fats, oils, and greases, which means Foam Buster and QuickSimL treatments will be effective. But there's an additional category where you might not technically have a foaming filament, but you might have so much filaments, or you might have some other things going on mixed with filaments, like flock breaking up or surfactants entering in the system. And then you can have a non-foaming filament act like a foaming filament. And in which cases, then you have to look at the treatment on a case-by-case basis, because there's just too many variables. Yeah, I have a question from Nick. How would something like Accelerator 7 interact with foaming? Accelerator 7 is an acceptable foaming treatment as well. I would still be using it with QuickSimL, and it would serve a similar role in this case to Foam Buster. I would say usually Foam Buster is going to be better for the uptaking of these volatile fatty acids specifically, and it provides a little bit more of a diverse range of nutrients for the uptaking of fats than something like Foam Buster would. But I have in some cases, if you have a nitrogen deficient system or a system where there's a lot of evidence of simple carbon substrates, like a lot of acetic acid building up, Accelerator 7 is a little faster acting than Foam Buster and could have a niche there as well with foaming treatments. But yeah, usually I would stick with Foam Buster. It just is a little more diverse.
Well-rounded.
Yeah.
Yep. And better for this specific particular application in terms of foaming filaments.
Oh, we have one more question. We'll get it. Do you recommend, from James, do you recommend dosing aerated digesters to control filamentous to prevent returning filaments to the head of the plant?
Actually, we just did some sampling with a digester that, yes, it is a good idea. And we went over that with the operator.
Oh, yeah. And
Going a little deeper, because that one was very different, because you approach the QuickSime and the Foam Buster is very much a aeration basin type treatment. So it was interesting when the lab got the samples from the digester and came back with that recommendation.
Yeah, and we have had cases where foaming filaments, particularly Microthrix, have been growing in aerated digesters. Mm-hmm. And that's just from, taking a lot of grease from a primary clarifier and sticking it in the digester in these cases. It turned out to like the environment, but the treatment ends up being very similar, whether you're treating a digester or the rest of the system.
So, yes, it will help from going back to that. And a long story short, yes.
Yeah. All right. Well, thank you all for joining us today, and we'll hope to see you in future webinars. But yeah, reach out to us with questions you want, and I'll also get back. My email is dan.s@teamaquafix.com. We have all of them on the bottom of this slide here, so definitely reach out if anything comes up, and I hope you have a nice rest of your day. Thank you.